Hello, hello. Good morning, good afternoon, good evening, everyone, wherever you happen to be joining us from. Welcome to the second actual live stream of the day today here on Believing Serverless. Before we get into today's incredible guest, I just wanted to quickly shout out some of the other things that are going on this week. It is a very busy week this week in the Believing Serverless community. So later on today, Tycho Franklin is going to be joining us talking about how he built a game server on ECS, which is some really cool kind of talks, actually, I think. Some of these kind of real world use cases that aren't necessarily your typical production app. And then for the rest of the week, we've got a whole load of different database talks. We've got FaunaDB joining us later on today as well. DynamoDB, a talk on DynamoDB tomorrow. And then on Thursday, we have Neon. If you're not aware of Neon, they're a fully serverless Postgres database provider. So there's some very interesting things happening this week. If you come and join the Discord, you can see when all these different events are happening. But enough of the rest of the week. Let's talk about right now. I am incredibly excited to be joined by serverless hero Yan Cui, talking to us about production WebSockets. How are you doing today, Yan?
Hey, man. Thanks for having me. And sounds like you guys are really busy right now.
Yeah, thankfully there's quite a few of us to kind of share the load around a little bit, and we can all kind of take some of these. But yeah, there's an awful lot going on. So I'll hand it straight over to you, Yan. If you want to bring your screen up, I can add that to the stream. And then
sure.
It'll be over to you.
Okay, that's okay. Let me start the slides. Okay, can you see my slide?
Yes, we can. We are good to go. Cheers, Jan.
Okay, sounds good. Today we're going to be talking a little bit about WebSocket. So we're going to cover, what are WebSockets for those of you who haven't used it before, and we're going to talk about some common challenges that you're going to see in production or things you should be thinking about before you take your WebSocket solution to production. We're going to look at some of the ways you can implement the WebSocket serverlessly, as in you don't have to run your WebSocket server yourself. Which, at scale, running WebSockets at scale in production is going to take quite a bit of work. Of course, it can be done. Lots of people have done it, and I will talk about some of the things that I've done in the past as well with my teams. But nowadays, if you can use a service to do all the hard parts of hosting and running a WebSocket server, then I think you should definitely do that. We're going to talk about some best practices for your WebSocket-based application as well. So I guess just in terms of WebSocket, one very common use case would be to push updates from the backend to the front end. So one of my last, my last full-time job, I was working for DAZN, this what we call Netflix of sports. So we are a sports streaming platform. You go to the dashboard for DAZN, you see some of the events that are happening live or later on, and you can see that some events will be starting on a particular time. And whenever a user goes to this homepage, one of the things they were doing prior to us implementing a WebSocket solution was that they'll be polling the backend to see, okay, has this live stream started? And if so, what is the URL that we can use to start showing the user the live stream? And as the system is fairly popular, at peak we get, at least when I was there a couple of years ago, we had over 2 million concurrent users, and now they're probably even much higher than that. So imagine every few seconds, or 2 million people polling your backend is probably not the most cost efficient and the most performant and scalable solution, right? This kind of polling mechanism. And so we invested into building a WebSocket solution on the backend. And at the time, this was 2019, there was no solution out of the box from AWS, certainly, that's able to scale to our needs. So much so that my colleague who implemented the WebSocket solution wrote a blog post about the limitations with the WebSocket solutions you get from AWS and how we went about building our own and some of the things that we did around multi-region and other things like that as well. But obviously, most people don't have the same kind of scaling needs that we have for WebSocket, and some of the things that we have learned along the way are also applicable to many other people. But by and large, if you're using services like AppSync or API Gateway, you're going to get very good scalability to help you support your application. Mind you, this blog post was written in 2019. This was back when AppSync WebSocket was not native WebSockets. And since they released a native WebSocket support after, I think maybe like a year after this blog post went live, we were able to, you would be able to hit the kind of scaling requirements that we had back then. So quickly about what are WebSockets. It's basically a duplex or bidirectional protocol that allows the client and the server to communicate with each other. And it's still built on top of HTTP. So essentially, you start by having the client make HTTP requests to the backend to initiate the handshake. The HTTP request looks like something like this. In terms of the headers, the important bit here is the upgrade header that says we want to upgrade this HTTP connection to be a WebSocket connection. And then the backend is going to receive that, and it's going to maybe do some validation, authentication, and whatnot. And if it agrees that, okay, let's open up a connection, then it responds to the front end, to the caller, with a response that looks something like this. And now the connection is open between the client and the server, and both sides can send messages over the WebSocket connection to the other side. So this is different from your traditional HTTP request in that the backend can initiate a request to the front end. So this will be cases where, for example, in the example I showed you earlier, where the backend can push updates to some content that should be refreshed on the front end, say, okay, this live stream has now started, and here's a URL. You can also do other things like sending push notifications while the user is waiting for some long-running task to complete on the front end. So they can do something in the UI, kick it off, and then when it's done, the backend can send an update, so you don't have to do polling from the front end. So both sides can send messages to the other side, and then at some point, either side can decide to close the connection. The backend might say, "Oh, we have two. Your connection hasn't been used for a while, so I'm going to close it so that I free up resources to support other connections." And the front end may say, "Okay, I'm a mobile app. I've just closed the app, so we're not going to receive any live notifications while the app is in the background or is closed. So I'm going to close the connection." And so either side can terminate the connection, and the other side will find out through a signal that gets sent to the other side. In terms of some of the most important things you want to do for security, when someone initiates the handshake, you want to do authentication and authorization to make sure that only the valid users user that's logged into your system are able to connect to your backend via WebSockets. And then the important thing to consider, and we're going to talk more about this a bit later on, is that, well, once you have this connection, you can send messages in both directions, but there's no protocol to what you send. You can just send, strings or send binary payloads, but there's no messaging, there's no sort of built-in messaging protocol that governs the structure of the messages. So that's why when it comes to developing an application that uses WebSockets, it's going to be a good idea for you to overlay your own messaging protocol so that you have a structured format for the messages that gets exchanged between the two sides. Okay, so with that, let's talk a little bit more about some of the options you have on the AWS in terms of implementing WebSockets solutions serverlessly. And then we're going to touch on some of the common challenges and how to think about them in terms of the pillars that you find in the well-architected framework from AWS. So API Gateway has supported the WebSocket for quite some time now. And the way it works is that API Gateway will handle the WebSocket connections. And you have two special routes that you can handle on your Lambda function, so that when a user is creating a connection to API Gateway, you can have a Lambda function that gets invoked when that connection is established. The reason for that is that for the backend to send messages to the front end, it needs to know the connection ID. And so the time when you find the connection ID for this user is on this onConnect hook. And then when the user is disconnected, you find out about that with the onDisconnect hook. So in that case, you want to update the connection ID in your own database so you can keep track of which users are connected and maybe match the connection ID to their user ID. Or if, say, this is a chat, so what's the chat group ID, for example, they are part of. So when someone else in the group sends a message to everybody, you can identify the users who's in the same group chat and then send them messages individually. And that's the important bit where you take a connection ID from your database, and then you make an API call to API gateway and use the post to connection API call. Unfortunately, this post to connection API call only takes one. You can only send one message to one connection at a time. There's no support for broadcast, as in, you can make one API call and that's going to send the same message to multiple users. There's no built-in support for that. So you will have to do it yourself. And if you say, from your API side of things, you see that a user makes API requests to your chat application to send a message to the group, then your Lambda function here is then going to have to then, based on the group ID, find all the connection IDs from DynamoDB, and then for every single connection ID, send a message to API gateway to say, I want to post a message to this connection ID. Of course, this doesn't scale that well when you have kind of like a broadcast that need to go to everybody. So, in our case, for the zone, for example, if we want to notify all 2 million people waiting in the lobby to start watching, Barcelona play Real Madrid, for example, that would be a match that will get millions of viewers. So then we have to scan and fetch millions of records from DynamoDB, and then for every single one of them, make a call to API gateway, which, as you can imagine, is not going to be very cost efficient or performant to do that. And this is one of the reasons why API Gateway is not such a great solution where you need to operate at scale, especially when you need to use the broadcasts. But what is actually good for, this is something that it supports bi-directional messaging. So as much as you can push messages from the backend to the front end through the WebSocket connection, the front end can also send messages to your backend. For example, you can run, the user might do something, and that can, instead of HTTP request, they can send it over WebSockets instead. And you can use the $sign default route key to then use that as a catch-all for all the messages that you get from the WebSocket connection. And then your Lambda function can, based on that, can pass that based on your messaging protocol, and then work out what is it the user has sent us. Now, as you can see, this is a very much low-level construct where you have to manage connection IDs yourself, and then when you want to send a message, you have to operate against a specific connection ID. There's no support for broadcasts, which makes it less suitable for a lot of use cases that you may find with that you may have for WebSockets. And one of the upside you have is that it supports bi-directional communications. Having said that, I also don't find it to be a very common use case that from the front end, for example, I want to send messages to the back end and want to do that through WebSocket. That's usually not the use case I have when it comes to using WebSocket. WebSocket usually is good when I need to push stuff to the front end from the back end. But for anything that I want to send from the front end to the back end, I can just make a normal HTTP request. So the bi-directional nature is not super useful in most use cases, but if you do have that use case, then this can be something that's quite useful. It also is just a raw WebSocket, as in there's no messaging protocol built in, so you can also overlay your own protocol depending on your application, so that you may have a specific way of structuring those messages. It can be binary based, or it could be just JSON. Most of the time when I see people using their own protocol, it's going to be some kind of JSON based messaging protocol. All right, so another popular option for implementing WebSocket serverlessly on AWS is to use AppSync subscriptions. So it basically is a mechanism that allows the client to subscribe to data change events you have on the backend. And it's actually part of the GraphQL schema. So you specify in your GraphQL schema a subscription type, and then the different subscription actions or updates you can subscribe to. So in this case, you will start by having a mutation, which is an operation that allows the user to do some update against some data that you have on the backend. And then when you have your subscription, so these are data updates that you can subscribe to on the client, you can then say, link this subscription to a particular mutation. So in this case, I'm saying that the add post mutation, whatever post that gets updated, that is then all used to automatically push updates to anyone who is subscribed to this added post subscription endpoint. So as to say on the backend side of things, or maybe another user who is the publisher, they make mutations against the backend to add a new post. And based on the information that gets captured in the output, that data is then pushed to the subscription endpoint to any subscriber who's subscribed to this added post subscription endpoint. So AppSync is taking care of the bit in the middle of taking the output from one mutation and sending it as an update, as a data change event to other people who are subscribing to this update. So as you can see, it's a high level of abstraction that ties into GraphQL schema, and you can also allow people to filter what data that gets pushed to them via the subscription endpoint by just adding a few arguments to your subscription operation. So in this case, if I say I only want to subscribe to, allow people to filter what posts they get updated, they get notifications about, so that they only get notifications about posts that are published in by a particular author, for example, and all the data that gets that can be used here can then be used by different subscribers to subscribe to different updates. Now, if the publisher publishes another post, in this case, the information that's captured in the output of this mutation, this post object, they can then again be passed along, forwarded to the added post subscription, and AppSync is then see, okay, we've got one subscriber here who's listening in, who's looking for updates by updates on posts created by this particular author, and only then would that subscriber receive the update. And the other subscribers who are listening for updates for other authors will not get the update. So you can get this nice filtering out of the box as well. So there's something that you get both the broadcast and filtering just by specifying a few things in your GraphQL schema. Now, where do these arguments come from? Can you just put anything here? The arguments doesn't come from the arguments for the mutation that is linked to, but instead is based on whatever data is available in the output of the mutation. So there are things that are, for example, included only in the output. Then whatever's in that output, you can then use as argument for your subscription endpoint, so that people can use that to filter what information or which updates they want to receive. Another couple of things there you go. Subscription arguments are matched against the mutation response field, not the actual argument. So in this case, a publisher would make a mutation request to update something in the system, to create a new post, new content, and whatever. And they're going to specify the objects, the data in the response. And that response is then used to push, is going to be used to match against the arguments for the subscription endpoints, so that the relevant updates are pushed to the people who are listening for those specific updates. Now, so what if you are providing arguments that doesn't exist on the actual post object? Then your subscription is not going to fire. You're not going to get anything ever. So it's important to make sure that those arguments that you have in the edit post, the subscription endpoint, matches what you actually can return in the response. And now, then the question is, are these the same response objects for the both mutation and the subscription response? The subscription response is only contain the fields that was requested by the mutation. So one of the kind of, I guess this is kind of one of the weird things about the GraphQL in this particular case is that when I'm making the mutation, I, as a caller, to make that mutation operation, I can specify what fields I want to get back. Unfortunately, that dictates what fields are then sent out to the subscriptions. So it might be a case that there are, in your post type, there are more fields, but because whoever making that mutation request did not ask for all the fields back, so the people that are subscribed to the subscription it's not going to get all the fields, and some of the fields are going to be null because the person who made the mutation request didn't ask for those fields in their response. So that's one of the weird quirks in terms of how this whole mechanism works. I wish it isn't like this, but nonetheless, that's just how it's been implemented. So when you're building a system using AppSync subscriptions, that is something that you want to keep in mind. Nonetheless, once you have the subscription response object, you can then be forwarded to all the subscribers, and the AppSync takes care of all of that for you. Another thing to keep in mind if you're using subscriptions with AppSync subscriptions is that the response type for the mutation has to be required, has to be non-optional, but the response on the subscription endpoint has to be optional. If it's not optional, then it doesn't actually work. I think you're going to get an error, or you're never going to get anything. I'm not quite sure why that is the case exactly, but that's just something that you have to do. Also keep in mind as well. This has stung me quite a few times when I first started working with AppSync subscriptions. Another thing you can do with AppSync subscriptions is that the whole system kind of AppSync manages all of that stuff for you. But how do you implement, say, authentication and authorization, for example, because the mutation is the subscription itself is also GraphQL request, so you can still use the AppSync's built-in authentication and authorization mechanism using Cognito, IAM, or Lambda authorizer. But additionally, you can put another layer of protection so that, a user, for example, if I'm building a Twitter clone, they may want to say, only allows you to get notification about your DM, so that I can't subscribe to James's DMs updates about James's DM, so that I can bypass the API authentication and authorization on the API side of things when I try to fetch those DMs. So the way you do that, in this case, for example, is that when someone makes a mention mutation, I can subscribe to my mentions. But then I want to be able to lock it down so that only the user can only subscribe to their mentions of their profile ID or the user ID. So you can do that by implementing a custom, just implementing a Lambda, AppSync resolver. VTL resolver or JavaScript resolver, so that you check the user ID in this argument against the user's user ID as resolved by Cognito, for example. So that way, I know when I try to make a subscription request here to subscribe to the mentions for James, my request will fail because I'm going to fail the authentication check. The nice thing about the AppSync subscriptions is that it's really easy to use. It's a high-level abstraction that gives you, you don't have to manage the connections yourself, and you've got the built-in broadcast support. All it takes is just you subscribing to the right thing, and then someone makes a mutation, and you get those updates automatically. But it's just for subscribing to updates. Is in terms of use case, it's not bi-directional. I cannot use that WebSocket connection to send messages to the backend. Instead, if I need to send messages to the backend, I have to go through the GraphQL API itself, which, as I mentioned before, that's absolutely fine for me, for my use cases. And I only ever need to, I only have use cases that requires a WebSocket connection for the backend to push information to the front end. But probably a bigger sort of hurdle to using this is that you have to speak GraphQL. This is using WebSockets to deliver data change events, but the whole thing is still wrapped around the GraphQL. You have to use GraphQL to do your mutations, and then you have to use GraphQL to subscribe to the data change events. And so it's not something that you can use as a raw WebSocket for your own application if you don't want to speak GraphQL in any way. So those are the two main options. There's also IoT Core as well, which gives you bi-directional WebSocket connection, but that's tied to MQTT, which is another messaging protocol over WebSockets, and that's typically used for IoT devices. But you can actually use it outside of IoT use cases as well. So last couple of minutes, I want to spend just talking about some of the things you want to think about and also common challenges when you come to making your WebSocket application production ready. And when it comes to talking about production readiness, I want to always just refer to the pillars we have in the AWS well-architected framework, starting with operational excellence. And this is where you want to have good observability set up for both the front end or the client and the server side, so that all of these things happening in the system, you have some way to capture what messages get sent, what messages are received, when the connection was closed and established, and so on. This is perhaps even more important for debugging because unlike with HTTP requests, which many of the frameworks and tools, API Gateway, for example, will have their own logs for when it's communicating over. It is when it comes to bidirectional messages over WebSockets, you miss out some of those built-in logging and observability that you may get from other tools. So it's more on you to make sure that in your application code you are logging the right information in places where you are processing messages and you are sending messages over the WebSocket connection and so on. The other important part is making sure that you have you're not just dealing with raw strings over those messages, because that's just not a scalable solution. You want to instead have your messaging protocol so that you can include things like timestamps, IDs, and various other things like that that helps you add metadata about the messages to the conversation you have between the client and the server, but also allows you to have a better error handling so that you have a structured way to return errors to the front end. If the front end is sending you a command through this WebSocket connection and that command is invalid or you encounter some error, you have some structured way to send back an error, and the front end can then, or the client can easily distinguish that from a normal successful response. And because you also have this, and by having a messaging protocol around it, it's also easier for you to later change your mind to say, okay, we started with WebSockets, that's great, but yeah, it's getting a bit old. We don't really want to use this for some reason. So you can then take your solution and more easier to support it over to just run over HTTP or some newer technologies that becomes available, because your application is speaking its own messaging protocol. You're not depending on the specific transport layer as much as if you were to just sending raw messages over the WebSocket connection. Also, importantly, it allows you to add another layer of authentication and authorization. So the WebSocket connection, the handshake, just allows you to say who can create a connection, but based on the message they're sending. For example, the AppSync subscription case, well, we also want to stop people from doing things that they shouldn't be allowed to do, even if they have a connection, a valid connection. So in this case, would be me subscribing to updates for James's mentions or DMs and so on. So having your own messaging protocol, again, allows you to better support those different authentication and authorization use cases, which then falls nicely into the conversation about the security. And again, there's two main things you want to think about in terms of security is the authentication and authorization at both when who can open up the connection, and once they open the connection, what are they allowed to do via this connection in terms of mostly from from the client to the backend, what kind of things they can request for over the connection, and how do the backend authenticate those requests to make sure that they're not asking for information. Users can't subscribe to updates to other people's data, which would then if you don't do that, then you can quite easily open up loopholes that allow people to get information about other users, which they shouldn't be allowed to do. In terms of reliability, I think one of the nice things, one of the great things about the time we live in today is that we can just use things like API Gateway and the AppSync and IoT and maybe Memento topics as well, so that the hard part of building a reliable, resilient WebSocket server, and most of that is handled by somebody else. They are doing the hard parts, and so we can focus on the easier things, which is just how to write the front end and the back end code so that we can reliably, say, recover from a disconnect. Some networking issue happen, we get disconnected, and so we have to have some mechanism to automatically reconnect. And for application that requires higher level of availability than we can get from a single region, think about the excuse me, think about how we can extend our application to work across multiple regions. And this is something that the team at the Zone spent quite a bit of time just working out how to do that correctly, so that when we hit capacity in one region, we can then using Route 53 and DNS around users to start connecting to another region and so on. Do it in a way that's seamless to the front end to the client. The next pillar I want to talk about is performance efficiency. How do we build systems that can scale and performs well? Again, the nice thing about using services, making it mostly someone else's problem, is that with AppSync subscriptions, the AppSync team has built something that can scale to millions of connected devices and users with no problem, and you can also handle a large burst of users all trying to connect at the same time. But it's still up to you it's still your responsibility to make sure that you load test the system, so that AppSync is great, looks good on paper, it sounds like it's something that we should be able to use, but can we actually use it at our sort of scale or context? So make sure that you're load testing against your own particular use case. And this was something that we found with the first version of AppSync WebSockets or subscriptions, that it was not using native WebSocket, and it was I think it was piggybacking off IoT or something like that. And so even though on paper, it take all the functional boxes, but when we did a load test against it, we found that the maximum number of connections you can have is way too low for our use case. And so this is why this blog post was written back in 2019, and then about a year later, this kind of second version of this AppSync WebSocket was using native WebSocket, and so after that, they were able to handle the kind of millions of connections that we're talking about here. Using a service, but making sure that you use the right service for your particular use case, and load test it to make sure that it's fit for purpose for your particular use case, is probably the most important thing when it comes to making sure that you've got a performant and scalable solution for your WebSocket application. Lastly, cost optimization. And for those of you who watched the last keynote, the last re:Invent keynote, Werner talked about the Frugal Architect website that you should definitely check out. And on there, he's got 7 laws for Frugal Architect, and I think the 2 of them are particularly relevant in this particular case here. Is that you want to have systems that align with the cost of doing business for you, and also architecting is a series of trade-offs. And if you think about the different solutions that we talked about earlier already on AWS, AppSync, API Gateway, and IoT Core, they all charge you against based on the number of messages you're sending over the connection, but also they're charging you for the connection time. So if you have a million people all connected at the same time, and you're connecting for a really long period, then that can potentially be a significant amount of cost compared to the number of messages if you're not doing an awful lot of things with those connections. So they just say connecting to get updates when there's update, but maybe for most of that connection time, there's no update. So you're not really paying much for the messaging, but you're paying a lot for the connections. And if your application is going to grow with more users, and every user is going to connect for some amount of time, then your connections time is going to grow with the number of users. But what if your revenue for your business doesn't grow with the number of users per se, but grows more with the amount of engagements, the amount of activities that people are doing in your application, and therefore the amount of updates that need to be sent over the socket? So in that case, it makes more sense for you to pick a service whose cost is going to grow with those activities, the engagement, as opposed to the amount of time that users are connected to your system. So this is why I really like the fact that Memento has got topics which support the WebSockets. So essentially, it allows you to subscribe to a topic and get updates through WebSockets. And the nice thing about them is that they don't charge you based on connection time. Instead, they only charge you based on the number of messages and also data transfer as well. So, which API gateway, AppSync, and IoT Core all charge you based on, also charges you for data transfer, except the data transfer rates are just the standard EC2 rates, which is a way for them to say, well, it's kind of complicated what you actually pay for EC2 transfer rates. We probably don't really know for sure, so you go check it out yourself. But for Memento, nice thing about them is that they just say it's flat out 50 cents per gigabyte of data transfer, which again, if your connections are not very active, you're not sending a lot of data over that connection, then most of your cost is going to be more tied to the connection time as opposed to the amount of messages or data transfer. So using Memento can potentially be a much more cost-efficient solution than using some of the other AWS hosted services. So when it comes to cost, I think I've said this before, and I've said this to say again, that in the cloud, every architectural decision is a buying decision. Essentially, when using AWS or any other cloud services, you're walking into a candy store, and you got all these different candies you can pick from. Many of them give you the same capabilities, and knowing which service to pick is a really, really important skill for modern day architects. And also, even if you are using, you are going to use the AWS services for different reasons, and maybe connection time is not a big concern for you. You still want to think about how long do I really need to connect, keep those connections along for. By default, I think API Gateway has a connection timeout of I forgot which is 30 minutes or something like that, and AppSync has got some timeout as well for the maximum connection time. And usually on the front end, you probably want to do some auto reconnect so that you don't lose a connection. But you also want to be very proactive in terms of disconnecting from the client when, say, if it's a mobile app, the mobile app has gone to sleep, then you don't need to connect to the backend anymore. Or if if your website, the user is moved away from a tab, or maybe, I guess as soon as they close the browser, you want to disconnect. So really be mindful in terms of how long you are connected for, so that you're not overrun on your connection time related to the costs. Okay, so those are the 5 pillars. There's also the sustainability pillar in the well-architected framework, but I couldn't think of a way to kind of link that to WebSockets, so we're going to skip it for now. But I hope that gives you some ideas in terms of the kind of common challenges you're going to run into, and some of the things that you want to do to address those challenges, and also how the different serverless WebSocket solutions work on AWS, and if whether or not you want to consider using Memento instead. And if you guys got any questions, feel free to just fire them at me. I'm happy to pick them up.
So we have had some questions, Yan. Can you actually hear me? Okay. Has the audio gone? Okay,
yeah,
cool. So when you were talking, I had a lot of notifications in StreamYard saying your mic is disconnected, your camera's disconnected. So you can hear me okay. So we're all good. So there was actually one question in the chat from David Baruzzi. So you talked about API Gateway and AppSync WebSockets, API Gateway being good for direct messaging and AppSync good for broadcast and subscriptions. Is there a sweet spot, in your opinion, for IoT and Memento topics? And I know you talked about Memento a little bit, but do you see these as like different use cases? Is there a sweet spot where all of these fit?
Yeah, I think Memento topics is really also so you've got the API gateways give you raw WebSocket, and AppSync gives you GraphQL flavored the WebSocket in terms of communication protocol, and I guess the Memento gives you topics gives you a raw WebSocket on topics. And whereas IoT gives you MQTT flavored WebSocket protocol on topics. And again, both of them are bi-directional. So if you need the bi-directional, and I guess IoT Core was kind of built with IoT in mind. So a lot of the IoT devices, they do need to send telemetry data and things like that to the backend system, and they need to receive updates in terms of maybe firmware updates and other things like that from the backend, or maybe to remotely disable various different features. So there are IoT specifically has got some really, use case, very common use cases that works well with IoT Core. and is also tied to MQTT. And of course, if you want to use that in your normal web application, then that means you kind of have to speak MQTT to communicate with the backend, which is kind of weird in a way. Because it's just not a very common protocol people are gonna be familiar with, but in the IT world, it's something that that people are so quite familiar with. So that's I guess that's the kind of one of the sort of use cases for that. IoT is kind of not nice for that, but Memento Topics on the other hand gives you topics that you can subscribe to, but it speaks the raw WebSocket, which means you can actually just overlay your own messaging protocol on top of that. And so it's pretty great for building things like web apps, things like a chat app, for example. You can still subscribe to, one topic could be a chat room that you can subscribe to any sort of communication from everybody in that particular chat room, and you can. The backends can send messages to it. You can send messages to the topic yourself, and so there's excuse me, and there's no MQTT involved, so you can develop your own protocol that's I guess fit for your particular use case.
Awesome. Yeah, I hope that answered your question. That's actually one of the questions I had as well while you were talking, Yan, is like, what are the different, when would you use one, when would you use the other? It sounds to me like GraphQL and AppSync is better for like really large scale. Like I want to send a notification to everybody. Whereas things like API Gateway, WebSockets, and maybe even Memento Topics are better like, I'm placing an order on a website and I'm sending notifications about my specific order, which means that the notification's only coming to me personally, right? It's not being sent out large scale.
Yeah, and with the Memento, you can also they've got this authentication mechanism called token vending machine. So you can use that to control who can subscribe to what topic. So again, you can have a similar concept that I talked about for AppSync subscription, whereby you can say users, so your DMs that can be a topic, and only you are allowed to subscribe to the topic that with your ID in that path, so that someone else I can't subscribe to your DMs updates, but the backend can send updates to you whenever you get a mention, and just send a message to your topic, and you get it if you subscribe to it, but the other people won't be able to do that.
Yeah, which is
you can do the same thing with the IoT core as well. You can configure IAM permissions so that you can only subscribe to specific topics.
Nice. Yeah, like authentication, authorization. Again, that was one of the other things I noted down before you got into it when you were talking, is about authentication and authorization. How do you stop people being able to, like you said, how do I stop myself being able to see your DMs? But it sounds like a lot of that kind of stuff is built in.
For API Gateway, it's not API Gateway because it's just a raw connection. So that's something that you have to build yourself. But for the other three solutions we talked about, there's a built-in mechanism to support that.
Perfect. Awesome. There's one other question I had actually that I'd noted down when you were talking. So with all these, like it sounds like the initial connection is a bit more involved than just like making a HTTP request. Does that affect latency at all, or would you typically set up your own connection kind of asynchronously, like in the background? Like, so how does that affect like system performance, system latency, particularly in like a front end application, or is it irrelevant?
Yeah, so the connection itself, usually, I mean, I guess depending on your application, usually that most of what you're doing is still, for example, you go to a website, you start using some kind of a chat application. The main bit that's sort of more performance sensitive or latency sensitive is more the initial page request, HTTP request to render the page.
Yeah,
and then you can create a connection. The connection just allows you to start sending, receiving real-time messages, and so it's probably less latency sensitive in that sense. At least in most applications I've come across. Of course, for the example I talked about, it's just about the connection is just for people to receive updates when an event goes from pending to actually live, so that they can get the information and start the render and start the polling pulling down the live stream and start showing that to the user. So it's not something, the performance, the latency bit is rendering the page in the first place. So normally the connection part is sure, it takes a bit longer, but it's also usually not part of your critical path in that sense.
Yeah, that makes a lot of sense. Awesome. Well, there's no other questions that I've seen come in, Yan. You've answered all the questions I had, and like I said at the start, this is a technology that I've not used myself very much, at least in production. So it was super insightful for me. I think we were saying just before we came online that this is the kind of cool thing about doing this, and obviously you doing your podcast, is that you get to learn all these really cool things and you get to talk to all these amazing people. So really do appreciate you spending time with us today, Yan.
No worries. So thanks for having me.
Awesome. And to everybody else listening at home, we will see you back here live on Believe in Serverless in about 5 hours with Tycho Franklin. It's all confusing with time zones. Like I've been working internationally for a long time now, and I still get confused with time zones. But in about 4 to 5 hours, Tycho Franklin's going to be live talking about building game servers in ECS Fargate. So Yan, thank you again. Really appreciate you being here. And we'll see you all soon.
Cheers, guys. Okay, bye-bye.